Alright, so this is the beginning of Chapter 6. This is 6-1 on polygons. So far we've studied a bunch about triangles, and a triangle is a polygon, but we want to expand this into shapes with multiple sides. So we'll still be including our study on triangles in this section, but now we're going to be talking about four-sided figures, five-sided figures, and so forth. The root word here, poly, means many. What I want you to do is copy down this chart. You should have a triangle, a quadrilateral, a pentagon, and a hexagon drawn. And then I want you to write number of sides. We're going to let that variable be n, the number of sides a polygon has, the number of triangles, and then the sum of angles. Don't worry about what all of this means just yet. Copy down the chart, pause the video, copy it down, and then we'll continue. So as we look at this, the first row is pretty easy to figure out. The number of sides we're just going to write here as 3, 4, 5, and 6. That's the number of sides this polygon has. Now the number of triangles, I want you to figure out the number of triangles each shape can be broken down into in a unique way. Now if we have, suppose, let's see, add a new page. Sometimes in this class we'll be given a polygon, say like this 7-sided figure right here, and I'll say break this thing down into triangles, and you'll start from the center. You say, okay, if I start from the very center and draw a line to each vertice, how many triangles do I get? Well, it's got 7 sides. You're going to get 7 triangles because it also has 7 angles. This is not how I want you to do it for our chart. We will learn to use this method sometimes later on this year when we're trying to figure out these interior angles, but that's not what I want you to do today. What I want you to do today, if you have that same 7-sided figure, I want you to pick one vertice, and I want you to draw a line from that vertice to the other sides. So I'm going to pick this bottom vertice right here and draw a line to each angle on the polygon. And now we get a different number of triangles here. It's not 7 triangles, but count how many triangles I have there. I've got 1, 2, 3, 4, 5 triangles in it. That's the number I want you to use when you're filling out this chart over here. So let's go back to our chart. Do the same for this chart. Draw and see how many triangles you can get. Pick one corner and draw a line to the opposite corners. See how many triangles you get there. So pause the video and try that out. And now I'm going to go ahead and do it for you. So if you didn't pause it and try to do it. If you did pause it, welcome back. So I'm just picking one vertice and I'm drawing a line to the other vertices from that one vertice. Now, count the number of triangles in each one. Here I've just got 1. So I just write a 1 right here. Here I've got 1, 2. 2 triangles. Here there are 1, 2, 3 triangles. And here there's going to be 1, 2, 3, 4 triangles. Don't forget when we did 7, how many triangles did we get? That was on this page right here. We had 1, 2, 3, 4, 5 triangles. So a 7-sided figure has 5 triangles in it. So this is all just for us trying to recognize a pattern here. Now there's 2 patterns we can recognize. One, sometimes a student will see this row right here and go, oh, it's just counting up from 1, 2, 3, 4, 5, 6, and so forth. But there's another pattern I want you to notice, because what I want you to start to say is, if I give you the number of sides in a figure, you tell me how many triangles I can make using this method. Well, it's pretty easy to say, well, 7 is going to be the next number up from 4, which would be 5 sides, and 8 would be 6 triangles in it. But what if I told you a 100-sided figure? You wouldn't want to count all the way up to see how many you got there. So the pattern is, yes, it's increasing by 1 triangle. You increase it by 1 side, you add 1 more triangle to it. But I want you to look vertically here and look for a pattern. So we got 3, 1, 4, 2, 5, 3, 6, 4. Notice what we're doing is we're saying minus 2 to get these numbers on each one. So we're taking the number of sides and we're subtracting 2 from it to get how many triangles we can make in the figure. And then this is going to take us to the sum of that figure's angles. Here we all know, and we did this in a previous chapter where we proved every triangle has to add up to 180 degrees when we add up their angles. So I know one triangle is going to be 180 degrees total. But right here, if I'm talking about a 4-sided figure, now what I've got drawn appears to be a square. It doesn't have to be a square or a regular figure. It's just more convenient to draw it on this chart. But if it's a 4-sided figure, even if it's something like, let's just use a regular parallelogram. Let's see. Even if I just have like a parallelogram, when I go to divide this thing up into the number of triangles, if I pick one corner, draw it to all the other corners, I still end up with 2 triangles. Now, if we look at this 4-sided figure, we've got 2 triangles. Well, there's going to be 180 degrees in each triangle. So, since I've got 180 degrees in this triangle, 180 degrees in this triangle, if you add those up, you get a total of 360 degrees in that triangle. 3 triangles here, 180 in each. I can say 3 times 180. I get 540 degrees there. 4 triangles, 180 degrees here, here, that's an 8. 180 here and 180 here. That's 4 times 180. That gives me 720 degrees. If I looked at my 7-sided figure, if I drew my triangles in here like this is why we don't want to draw our triangles like this, I would have a total of 7 triangles times 180. And the problem is all of these angles right here are not a part of the original angles to the polygon. That's why we want to draw our triangles like this. Notice that this is part of the original angle of the 7-sided figure here. These 2 add up to the original angle. These 2 add up to the original, as well as these and these. They all add up to this original angle right here, going all the way around. This one is an original angle, and then these 5 angles right here, they add up to this original angle. So there's no extra. If you look at it, I'll flip back to the other page. If we drew it like this, all of this is extra. These are not part of the original angles on the 7-sided figure. So here I get 7 triangles. That's way too many triangles than I should be getting for this method. Here I get 5. So we can say 180 times 5, and we get 900 degrees is what all 5 angles of a 7-sided figure will add up to. Now, when we look at this pattern, we said, yes, we notice a pattern. We take the number of sides a figure has, subtract 2 from it. That gives us the number of triangles we can make using that method I showed you. If there's 180 degrees in each one, we're going to times that by 180 to get the sum of the angles. So to see that formula written again, n minus 2 stands for the number of triangles. I multiply that by 180 because each triangle has 180 degrees in it. So this is an equation or formula that you need to know. It's not on the formula sheet for the Geometry SOL, and I want you to understand where it comes from. I'm not just giving you this and saying, memorize this and move on. I want you to know that n stands for the number of sides in a figure. Subtract 2 from it and you'll get the number of triangles. Since each triangle out there has 180 degrees in it, we multiply it by 180 to get the sum of the angles in a polygon. Now, this method works. Let's look back at our quadrilateral. If we start with a 4-sided figure that resembles a square here, but notice we could make a rectangle. We could make, let's go ahead and draw our rhombus again. We could draw a rhombus. We could draw a trapezoid. As a matter of fact, you could probably just draw any 4-sided figure you want. Let me draw some weird ones here that we may not normally see. Let's see. And let's go ahead and make like a kite looking thing here too. Well, that turned out to look like a rectangle. But any of these, notice I can divide into 2 triangles using that method. Typically I don't draw this side and this side. You can just say, hey, all of these get divided into 2 triangles. So it doesn't matter if it's all the sides are the same and all the angles are the same. If it's a four-sided figure, the angles add up to 360, because no matter which figure I draw, I can divide it into two triangles like that. Now, what we call all sides the same and all the angles are the same, we're referring to a regular polygon. So all of these drawings in your chart were regular polygons. Going back to that chart. So this was a regular triangle. This was a regular quadrilateral, also known as a square. This was a regular pentagon. This was a regular hexagon. And then later on we drew a regular heptagon. But they don't have to be regular for this equation to work. Just like a triangle does not have to be equilateral for all the angles add up to 180. You could draw many different triangles out there. They all add up to 180 degrees. And I just showed you how you can take a quadrilateral and draw it a bunch of different ways. You get two triangles every time. It's always going to add up to 360. Same with the pentagon. You think of the pentagon picture that we see on TV where they talk about the Pentagon near DC. Well, it's a regular pentagon, but it doesn't have to be regular. When you think of octagons, an octagon has 8 sides. So we could draw a regular octagon. That's typically what you see on a stop sign, is a regular octagon. No, I drew a nonagon. That's a 9-sided figure. Here's our octagon. That looks more like a stop sign. But remember that an octagon does not have to be regular like that. Let's see. Let me try drawing one. There's one side, 2, 3, 4, 5, 6, 7, 8. All right. This is an 8-sided figure. They add up to the same amount that this 8-sided figure adds up to. How much is that? Well, let's write it out. If we said 8 sides minus 2 would tell me how many triangles I would draw using that method. 8 minus 2 is equal to 6. And then since each one is a triangle, we multiply it by 180 to get our answer. So 6 times 180 is the same thing as 600 plus 480, which gives us 1080. I was doing this on paper, so if you were confused about this, just type that in your calculator. You'll get 1080 is the sum of all the angles in this guy, 1080. Let me try drawing that differently, 1080. And it's the same for this one, even though that this one is not regular. They all add up to 1080. I still got the shape recognition pen on, that's why that's coming out so weird. So anyway, I want you to know that this n minus 2 times 180 works for the sum of a regular convex polygon. Doesn't matter, I'm sorry, regular or irregular. We'll have some special properties about ones that are regular coming up soon. What I mean by convex, though, our study for most of this stuff is always going to work for convex polygons. Convex, they don't bend inward. Let me give you an example of what we call a concave polygon. That would be bending inward like this one. We typically don't study polygons that bend in like this. They're always going to be what we call convex, where they're enclosed and they don't bend in. So you can think of like a heart. This would be another concave one. But we don't study these where they bend in like that. Those are concave. So that n minus 2 times 180 rule doesn't really work here because this is a super large angle right here. It's greater than 180. This is a convex polygon. That's what we'll focus our studies on. So here's some examples if you want to look at them. This is the one for a triangle. And what I'll do is I don't want to take up too much of your time in this video. So these are ones I've calculated out. You just pause the video if you want and try them out. So there's a 3-sided figure. Here's one for a rectangle, a pentagon, a hexagon, a heptagon we've already done, an octagon we've already done. A nonagon, you'd say 9 minus 2 times 180. That would give you your sum there. I'm going to skip along. Let's look at a 102gon. And you're thinking like, a lot of times students will laugh when they see that because they think I'm joking around. But instead of, I'm sure there's names for things once we get past 10-sided figures. But honestly, you don't need to memorize them. What all this means is that you've got a figure with 102 sides. Just like the one before, it's a 14-sided figure. What does a 14-sided figure look like? Well, I'll draw one for you. Right there's a 14-sided figure. You don't want to have to try to draw this thing out and draw your triangles. If you want to know what the sums of the angles in a 14-sided figure like this are, notice these are all very large angles. They're almost 180. So it's going to be a large number. You're going to say 14 minus 2. That gives you 12. And then you're going to take 12 times 180. And then whatever that answer is the sum of all those angles. Let me see if I can grab my calculator. I don't have one handy. Let's see. So punching that out, what I got was 2160. Now, notice this almost looks like a circle. In fact, I've got another one. Let's see. What's the highest one I can make using this program? 16 sides. This is what a 16-sided figure looks like. You can't really tell much difference, but it's getting closer and closer to a circle. So if I had one that did 102 sides, it really would look like a circle. I don't want to draw that, and I definitely can't draw all of the triangles, but I know my rule here that if I take the number of sides, 102, and subtract 2, I get 100. That's the number of triangles. And now I'm going to times that by 180, and that, because each triangle has 180 degrees in it, so that's going to give me 180, and then add 2 zeros to it. So it's going to be 18,000 degrees. That's what they all add up to in a 102-gon. Now, I want you to think about something. If we have a regular triangle, so it says if it's regular, what's the interior angle measure? I just want to know, what is this angle measure right here if it's regular? Remember, regular means all the sides are the same and all the angles are the same. So, by the way, what's another word for a regular triangle? It's equilateral triangle. We have a special word for those. I know that all the angles add up to 180 because it's a triangle, and each one is equal. So if I called each one x, well, I know that x plus x plus x equals 180. X plus x plus x equals 180. Combine your like terms here, you get 3x equals 180, or x is equal to 60. Now you could have that memorized because we've already talked about that a bunch, but I just want to show you the method because we're going to look at other figures and see how it's kind of like the same thing for that. So if this quadrilateral is regular, what's its interior angle measure? Well, a regular quadrilateral, we've got a special name for that too, and it's called a square. All the sides are the same, all the angles are the same. And so you probably have it memorized that that's 90. But let's pretend like we don't know that it's 90. Well, if I call each angle x, because I know they're all equal, so whatever, if one's called x, the others can be represented by x as well, then I've got 4 x's that give you 360. Divide both sides by 4 and x equals 90. If it's regular, what is its interior angle measure? Pause the video, see if you can figure out what this value of x is here. Alright, so how many x's would I have here? Well, be careful, I skipped from 4 to 6, so I know it's a hexagon. So it's got 6 sides, which means it has 6 angles, and those 6 angles all add up to give you 720. Divide both sides by 6, and you get x equals 120 degrees. So if it's regular, the interior angle measure here is 120. Now I want you to think about an equation that we could use to represent, let's say if we went back to our 102-sided figure, what's the measure of an interior angle of a regular 102-sided figure? So what we're doing is we're taking the sum of all the angles and we're dividing by the number of angles. Now that's not very mathematical looking. Let's write that out again. I said earlier, I said if you say n minus 2, that's the number of triangles, times 180, that gives you the sum of the angles in a figure, in a regular, well, it doesn't have to be regular or irregular polygon. Sum of polygons angles. And now, so if I just substitute this in for up here, we got n minus 2 times 180. And then we're going to divide it by the number of angles. Well, the number of angles is equal to the number of sides. So if you had 4 sides, you got 4 angles. You got 10 sides, you've got 10 angles. And so the number of sides is represented by n. I can also let that be n right here. And this gives us a different equation. This gives us the interior angle of a regular polygon? So I want you to keep something in mind, that this is regular only, okay? Sorry, not regular only, it's regular or irregular. I'm getting it backwards now. Don't want to confuse you. This can be regular, it can be irregular. This guy is regular only. Has to be a regular figure because we know all the angles are equal. Here it doesn't matter if the angles are equal or not. Now, let's look at another case. If this figure is regular, what is the exterior angle measure? So think about that. Come up with your answer. Well, I know if it's regular, we just said it a second ago, this angle must be 60. Remember that these two angles here form what kind of angles? From chapter, I think it was 1 that we discussed, it should be a linear pair. And I know linear pairs add to 180. So 180 minus 60 gives me 120. That's the exterior angle there. Now, we've got 3 exterior angles on a triangle. So if we've got 120 here, 120 here, and 120 here, what do they add up to? Well, they add up to 360 degrees. All right, we're just looking for patterns here. Look at this one. If it's regular, what is its exterior angle measure? Well, I know the interior is 90. Once again, we've got a linear pair. So that guy on the outside must be 90 as well. If you got 4 of these and each one's 90, what do they add up to? Well, they're going to add up to 360 also. Look at this one. Here we have a, what, 1, 2, 3, 4, 5-sided figure. What's the interior angle on a 5-sided figure? The interior. I know it's asking for the exterior, but tell me what the interior here is. Well, I know that n minus 2, that's 5 sides, minus 2 gives me 3 triangles, times 180 in each one. That means all the angles add up to 540. If it's regular, all the angles are equal, so 540 divided by 5 gives me 108 degrees right here for the interior angle. The exterior angle has got to be supplementary, so 180 minus 108 gives me 72. So the exterior angle is 72 degrees. Now, it's getting kind of cut off here. I'll drag this in. Let's do this. So we said each angle is 72. Whoops. Still messing it up. I got 72 right here, 72 right here. How many exterior angles do I have? Well, it's the same as the number, this one right here. It's kind of falling off the screen, but it's 72, and this one's 72. I got 5 of them. So 5 times 72, guess what that is? It's 360. So we should be noticing a pattern here, and it's that all the exterior angles of a convex polygon add to 360. Now, once again, this is true whether it's regular or irregular. They always add to 360. So even if you had, like, let's draw a triangle that's not regular, like this, all the angles will still add to 360. Okay? If it's regular, all those exterior angles are the same. So if I'm looking at this one, notice all of them are 72. They're all the same. And so that becomes helpful because there's a new equation I can use here, and I let n be the number of sides and e is the exterior angle, so the number of sides a figure has times the exterior angle equals 360. So notice if we go back and look at this one right here, I've got 1, 2, 3, 4, 5 sides, that's my n, times the exterior angle gives me 360 degrees. And that works for regular figures only. So NE equals 360. So let's try this one. It says, find the interior angle of a regular 11-agon. Now, before we actually go that far, I just want you to figure out what is the exterior angle of a regular 11-agon. So I know this says, well, we know 2 different ways. Let's just draw out an 11-sided figure so you can see it. There's an 11-agon. Let's draw the exterior angle. So right there's our exterior angle. Figure out this exterior angle right here. How can we do that? Use NE equals 360. NE is equal to 360. It's got 11 sides to it, so I'm going to put 11 right here. E is the exterior angle I don't know. I can use this equation because the problem says it's regular. And so you just divide both sides by 11, and 360 divided by 11 gives you 32.7. 32.7 is the exterior angle. Now, let's answer this question. It says, what is the interior angle though? Well, I know the exterior and the interior must be supplementary, so I'm going to say 180 minus 32.7, and I get 147.3 is the interior angle, 147.3. I feel like that was easier than using the other method to find the interior angle, but we can still use the other method. The other method was n minus 2 times 180, the sum of all the angles in an 11-sided figure, divided by the number of angles you have. So using the other method, because this thing says use both ways, this is one way right here. 11 minus 2 gives me 9 triangles, and 9 times 180 gives me 1620 for a sum of all these angles. There's 1620 degrees here. Divide that by 11, the number of sides you have, and you got each one is 147.3 degrees. So you can use that method to find the interior angle as well, whichever one you like. But what you need to know is this, that if this is regular only, we can use these two equations. So we can use n minus 2 times 180, that's the sum of all the angles, divided by the number of angles, gives you an interior angle. I'll just say one interior angle. Interior angle, and then you can use NE equals 360 to find exterior angle. That's for regular figures only. That means all the sides have to be the same, all the angles have to be the same. Now if you want to talk about regular or irregular, you say regular or irregular. Then we can say n minus 2 times 180. That gives you the sum of all angles. So here's a case where you have, it's irregular. One angle is y, this angle is y, this is 2y minus 20. So this is a 6-sided figure. So if I say 6 minus 2 times 180, I get the sum of all the angles. It's a hexagon. It's going to add to 720 because 6 minus 2 times 180 is the number of triangles. It's going to be 4. 4 times 180 gives you 720. And now I can say, hey, I know all of these angles must add up to this. They're not all the same, so I can't use the rule where I divide by 6. But I know that 2y, this angle right here is 2y minus 20. This one's 2y minus 20. Add those up. Add y to it. Add these two angles to it, add y to it, and I'll get 720 degrees. So instead of saying 2y minus 20 plus 2y minus 20 plus 2y minus 20 plus 2y minus 20, that's a lot to write out. Take up the whole board here. I'm just going to say I've got 4 angles that are 2y minus 20. So I'm going to say 4 times that. Plus, I've got 2 angles that are y. All of those angles added up is going to give me 720 degrees. Make sure you distribute here to both numbers. You end up with 8y minus 80 plus 2y equals 720. Combine your like terms, you get 10y minus 80 equals 720. Add 80 to both sides, you get 10y equals 800, or y is equal to 80. And when you substitute these in, you should get 80 here, 80 here, 140 right here, 140 right here, and all of these should add up to 720 degrees. All right, so what I'm going to do is, we're approaching 30 minutes on this video. I know that if you've stuck with me this long, it's a lot to take in. So I'll make a separate video going over some of the homework problems from this. There are other things that I could ask you. So I just wanted to make a video. If you missed class, here's a great way to get caught up watching this video. I hope it helped, and I look forward to seeing you in class.